Hello students. In this class, I'll be teaching you about random variables and probability distribution. Now let us look at what is a random variable. A variable whose value is determined by the outcome of a random experiment is called a random variable. You already know what is a random experiment. Some experiment which you conduct and you get some outcomes, that is called as a random experiment, and the value you obtain by doing the random experiment is called as a variable. And these random variables are usually denoted by capital letters, say x or y or some capital letters. And these random variables, the values of these random variables will be a real number, and these real numbers you combine and you form a set, and that is called as the range of the random variable x. Say for example, suppose you toss a coin twice, then the sample space is equal to h h h t t h and tt. Now I take let x represent the number of heads that come up with each sample point. So I'm finding x to be the number of heads that come up when you toss coin twice. So I'm taking a tabular column here. I write the sample point. These are called as the sample points, h h h t t h and tt, and x will be the number of heads that come up. So when you have in case of HH, there are two heads which are coming up. So I'll write the number as 2. HT is you have one head coming up, so I write it as 1. TH also one head comes up, so I write it as 1. And TT will be equal to 0 because there are no heads. And this is x is the random variable. So range of x will be, so what are the elements? It contains 0, 1 and 2. Since 1 is repeated, you can write it only once. So range of x is equal to 0, 1 and 2. Now let us look at, there are two kinds of random variables, that is discrete random variable and continuous random variable. So discrete random variable is, if the random variable takes on the integer values, then it is called as a discrete random variable. And if the random variable takes on all values within a certain interval, it is called as a continuous random variable. I have given examples here for discrete as well as continuous random variables. Now let us look at the next one, that is a discrete probability distribution. Now let x be a discrete random variable, that is it takes taking only the integer values. And suppose that the possible values it can assume are given by say x1, x2, x3 and so on, arranged in some order. Suppose these values are assumed with probability given by p of x is equal to xi is equal to pxi. So I denote this probabilities p of x is equal to xi as pxi, such that it has to satisfy two conditions. The condition is p of xi is always greater than or equal to 0 for all I. This is understood as probabilities are always positive. And this is always greater than or equal to 0 for all I. I will take the summation of these probabilities, that you should get it as 1. Then you call this kind of function p is called the probability mass function or probability density function of the random variable x, and this set xi with pxi, the set xi with pxi is called the probability distribution of the discrete random variable x. So this set xi comma pxi is called the probability distribution, wherein it has to satisfy two conditions, that is p of xi is greater than or equal to 0 or and summation p of xi is equal to 1. So when you have a distribution, we will find out what is the mean of the distribution. As we had done it in statistics, you can know what is mean. So if suppose I have a pxi is equal to fi, then mean is given as x bar is equal to summation fi xi divided by summation fi. This we have already learned for mean, where you have xi's and fi's. Now, since summation is, I have taken fi to be equal to pxi. So since summation fi is summation pxi, that is equal to 1, we get mean is equal to summation xi pxi. Similarly, variance is given as, variance is nothing but square root of standard deviation. So standard deviation, we already know what the formula, that is summation fi into xi minus x bar the whole square divided by summation fi. So this variance is equal to summation xi minus mu. I denote mean by mu, so I write it as xi minus mu whole square into pxi, because I've assigned fi to be equal to pxi, and summation fi is equal to 1 as fi is equal to pxi I've assumed. So this is mean and this is variance for any probability distribution, and standard deviation is equal to sigma, that is equal to root of variance. So that is how you find out mean, variance as well as standard deviation for probability distribution function. So next we'll solve some problems based on probability distribution. So three coins are tossed. A random variable x represents the number of heads turning up. Find the discrete probability distribution for x. Also find its mean and variance. So when a coin is tossed thrice, we have sample space S to be equal to this one. That is HHH, HHT, HTH, HTT, THH, THT, TTH, and TTT. When you're tossing a coin three times, you will get 8 outputs. Now, what the probability of HHH will be 1. There's only one element, 1 by 8. So total number of outcomes is 8. Number of possible outcomes is 1. So that is equal to 1 by 8. Similarly, all these elements, sample points, has the probability as 1 by 8. Now I take x to be equal to number of heads turning up. So number of heads turning up is, you can get the number of heads to be either no heads coming up, or one head coming up, two heads coming up, or three heads coming up at the max, because the coin is tossed thrice. So I take probability of x is equal to 0, that is no head. That means probability of, there is no head means it has to be t. So probability of that is equal to 1 by 8. Similarly, probability of x is equal to 1, that is only one head turning up. So that is equal to, you can look at the sample space and you can see which has only one head. So that will be probability of HTT plus probability of THT. This is the one. Next, probability of TTH. So each has a probability 1 by 8. So when you add it, you will get it as 3 by 8. Similarly, probability of x is equal to 2, that is 2 heads. Looking at the sample space, you can see what is how many two heads events are there. So probability of HHT, probability plus probability of HTH plus probability of THH. Same here, each has the probability 1 by 8. So this value is equal to 3 by 8. And probability of x is equal to 3 means that is 3 heads. That is nothing but probability of HHH, that is equal to 1 by 8. Now you have a discrete probability distribution for x as follows. Now x can be written as 0, 1, 2, and 3, and p of xi, as we have already calculated, you can write out what is p of xi. Now when we observe here, you have p of xi is greater than 0, all values are greater than 0, and when you add these p of xi, you will get it as 1. So this is the probability distribution. Now to find mean is given as summation xi pxi. Substitute the values xi pxi. So 0 into 1 by 8 plus 1 into 3 by 8 plus 2 into 3 by 8 plus 3 into 1 by 8. So when you simplify, you will get the answer as 3 by 2. Similarly, variance is obtained. The formula for variance is summation x minus mu the whole square into p of xi. Now substitute in each case. So x in first case 0 minus mu is 3 by 2. So 0 minus 3 by 2 the whole square into 1 by 8 plus 1 minus 3 by 2 the whole square into 3 by 8 plus 2 minus 3 by 2 the whole square into 3 by 8 plus 3 minus 3 by 2 the whole square into 1 by 8. So after simplification, you will get the answer as 7 by 16. Now we'll go for the next problem. Show that the following distribution represents a discrete probability distribution, and also find the mean and the variance. So as done earlier, from the given table we observe that each p of xi is greater than 0 for all x, and also summation of these probabilities, when you add it, you will get it as 1. Hence the distribution is a probability distribution, discrete probability distribution. Always remember these two conditions must be satisfied. P of xi is greater than 0 and summation p of xi is equal to 1. So as done earlier, the formula for mean is summation xi pxi. Substitute, you will get the answer. Similarly for variance also, summation x minus mu the whole square into p of xi. The same kind of problems, other problems, you can do it by yourself. Next, we'll go for the next problem. A random variable x has the following probability distribution. So this is the probability distribution which is given. We need to find for what value of k this represents a valid probability distribution. Also find p of x greater than or equal to 2 and p x less than 3. Now, for this to be a probability distribution, the condition is all these p of xi's must be greater than 0. And when you take the sum of these, that should be equal to 1. Then you call that as a probability distribution. So to get summation p of xi is equal to 1, we substitute now. Summation p of xi is k plus 3k plus 5k plus 7k, that is equal to 1. So you have k is equal to 1 by 16. Now this value is definitely greater than 0. So all these p of xi is greater than 0. Now let us find what is p of x greater than or equal to 2. So p of x greater than or equal to 2 is nothing but p of x is equal to 2 plus p of x is equal to 3. So that is p of x is equal to 2 is nothing but 5k. So we have k is equal to 1 by 16. So this becomes 5 into 1 by 16 plus p of x is equal to 3. It is 7k. So it is 7 into 1 by 16. So when you add, you will get the answer as 3 by 4. Now the next one is probability of x less than 3. So x less than 3 means that will be 0, 1 and 2 only. When you have is equal to, less than or equal to, so 3 will include. Since you have only x less than 3, you have the values only for 0, 1 and 2. So finding p of x less than 3 for p of x is equal to 0, x is equal to 1 plus x is equal to 2, you can as well do it as 1 minus p of x is equal to 3. The reason is when you add these all, you will get it as 1. Hence, 0 plus 1 plus 2 is same as 1 minus p of x is equal to 3. You can do it in both the ways, no problem at all with that. So this I'm writing it as 1 minus p of x is equal to 3. That is 1 minus 7 into 1 by 16, so 9 by 16. You will get the same answer when you do it as p of x is equal to 0 plus p of x is equal to 1 plus p of x is equal to 2. However you are comfortable, you can solve the problems. Now let us look at the next definition, that is mathematical expectation of random variables. So for a discrete random variable x having possible values x1, x2 and so on up till xn, the expectation of x is defined as e of x is equal to x1, p of x is equal to x1 plus so on plus xn into p of x is equal to xn. So you're multiplying each xi's along with their probabilities and taking the sum. So e of x is equal to summation I is equal to 1 to n xi into p of x is equal to xi. Now, when the probabilities are all equal, that is, all these probabilities are equal, then we have it as e of x is equal to x1 plus x2 and so on up till xn whole divided by n. That means when the probabilities are all equal means these values of these values will be 1 by n, 1 by n and so on. Say for example, when you toss a coin twice, you have the sample space as h comma t, and both are equally likely means both are happening equally. So probability of h is equal to 1 by 2 and probability of t is also equal to 1 by 2. So same thing applies here also. If the probabilities are all equal, that means the probability of each value will be equal to 1 by n. Hence, e of x will be equal to x1 plus x2 and so on up till xn whole divided by n. And this is nothing but the arithmetic mean. So, e of x in this case will be an arithmetic mean. So, the expectation x is very often called the means of x and is denoted by mu. You can also denote e of x as mu in this case. So there are some theorems on expectation which you have to know. So theorem one, this is without proof. So you just know that if c is any constant, then e of cx is equal to constant into e of x. If x and y are any random variables, then e of x plus y is equal to e of x plus e of y. Now let us look at one problem based on these this expectation. So a coin is tossed until a head appears. What is the expectation of the number of tosses required? So now okay, a coin is tossed until a head appears. So let I denote x to be the number of tosses required to get the first head. So then x can be obtained in the following ways. So event is, the first event is head. Suppose you toss a coin once, you get a head, you record it because you are taking x to be the number of tosses required to get the first head. So x will be equal to 1 and the probability of this is equal to half. So the next will be, suppose you toss a coin two times. So once you toss a coin, you get tail. Second time you toss a coin, if you get a tail, you won't record that event. You will record only those event when you toss a coin and you get the head. So the second event will be, the first you toss a coin, the tail you will get, and the second time you toss a coin, you will get as a head. So x will be as 2 because x denote the number of tosses required to get the first head. So number of tosses required to get this event will be 2. So probability of this is equal to 1 by 2 into 1 by 2, as tail and heads are equally have equally likely events. That is, both will happen with the same probability. So 1 by 2 into 1 by 2, that is equal to 1 by 4. And next one, you suppose you toss a coin three times and you will get it as T T H. Let x denote the number of tosses required to get the first head. Suppose you get the first head with the first toss itself, that is same thing as this one. So when you toss a coin three times, if you get the head as a third time, then x will be equal to 3 and this probability will be 1 by 2 into 1 by 2 into 1 by 2, that is equal to 1 by 8. Now, as I had explained in the definition, the expectation of x is given as summation I is equal to 1 to n xi into p of x is equal to xi. So here you already have the probabilities. So expectation of x is equal to, there will be infinitely many tosses which you can do. So x will also be keep on increasing and probability will also be there for every event. So E of x is equal to summation. Since there are infinitely many terms, I'll write it as summation I from 1 to infinity xi pxi. So xi is 1 in first case, 1 into 1 by 2 plus second is 2 into 1 by 4 plus 3 into 1 by 8. The next one will be 4 into 1 by 16 and so on. Now I denote this sum as S. So S is 1 into 1 by 2 plus 2 into 1 by 4 plus 3 into 1 by 8 and so on. Now to evaluate this sum, what I do is I multiply this S with half. So I'll get this as half S, that is equal to 1 by 4 plus 2 into 1 by 8 plus 3 into 1 by 16 and so on. Now I subtract these two. These two sums I will subtract. So I'll subtract left hand side separately and right hand side separately. So when I do that, I'll get S minus 1 by 2 of S because I take S as a common factor. So it becomes 1 minus 1 by 2 of S. And the next one will be, since it is a infinite series, I can subtract the terms like this. So 1 by 2 minus, I'll take the first term to be as 0 here. So 1 by 2 minus 0 will be 1 by 2 because I will subtract those terms wherein the denominators are same. So the next term will be 2 into 1 by 4 minus 1 by 4, that is 1 by 4. Next 3 into 1 by 8 minus 1, 2 into 1 by 8, that is 1 by 8 and so on. Now this is a geometric series and this geometric series has the first term and the sum of the geometric series is given as S summation is equal to A divided by 1 minus R. Now the left hand side is half S, that is equal to A, the first term is half divided by 1 minus 1 by 1 minus R, where R is the common ratio. Common ratio is given as A2 by A1. That is how you find the common ratio. So half S is equal to half by 1 minus half, that is equal to 1. So S is equal to 2. Therefore, E of x is equal to 2. I'll repeat it again. This is a geometric series with the first term to be 1 by 2 and the common ratio is also 1 by 2. To find the common ratio, you do it as the second term divided by the first term. That is how you find the common ratio. and the summation of geometric series is given as a divided by 1 minus r. So note that if you have to find out the variance of x, in this case you only found out the expectation of x. Now expectation is nothing but mean. Now to find variance of x, the formula is given as e of x square minus e of x the whole square. So for that, you need to first find out what is expectation of x and expectation of x square and then subtract these two. So expectation of x square is given as summation xi square into pxi. So you square all these xi's and multiply with its probabilities and then take the sum. That is how you obtain e of x square. So variance of x is equal to e of x square minus e of x the whole square. So that is all for today's class. You can do some more problems on expectations by looking into the exercises. Thank you. And in the next session, I'll be teaching about the binomial and the Bernoulli distribution. Thank you.